Hello everyone, today I'm going to talk about hepatotoxicity models in vitro. Hepatotoxicity is toxicity related to the liver, and there are two main types of drug-induced hepatotoxicity. Type A is the intrinsic or expected toxicity and occurs when the dose is above the therapeutic window, and type B is the unexpected toxicity. There has already been 900 drugs withdrawn from the market because of hepatotoxicity side effects that have been discovered after the commercialization. And this is actually the first cause of drug withdrawal on the market. Recently, because of ethical concerns and poor reliability, the scientific community in general wants to go towards more of an in vitro approach and reduce the need for animals. And this is very complex for liver testing because of its structure and composition. So there is really a wide range of drugs that have been proven to cause hepatotoxicity. Paracetamol and ibuprofen are both in that list, but this is also all a concentrations game, and hepatotoxicity occurs when the dose is exceeded. So in case of an overdose, these drugs will result in severe hepatotoxicity. There's also certain antibiotics that show sign of hepatotoxicity, and on the bottom of the slide you can see a few drugs that have been taken down from the market because of serious side effects. Cell death is usually the easiest sign of toxicity, but there are a lot of complex mechanisms behind it. For example, there's mitochondrial dysfunction, which results in loss of respiration for the cell. Oxidative stress can modify cell walls or other machinery of the cell. Protein modification, DNA modification, as well as depletion of enzymes or cofactors. The current big challenge in the field is to find an ideal in vitro model that can recreate most of the in vivo conditions in order to replace and reduce the number of animals that are used. So this ideal model should be robust and reproducible as to make it widely available and let other groups use it as well as industry to reduce the number of animals used. It has to mimic the liver in a lot of things, for example in flow, in function, as well as in structure. Another very important factor is the heterogeneity in human populations. The goal is to also find models that can somehow predict these changes and these modifications, because often unexpected hepatotoxicity is a result of this heterogeneity in the population. Another important factor is the lifespan of the model, because as you will see now, a lot of these models only last a few days and the testing that can be done is very limited. So the first model I want to talk about is the liver slices. As you might have guessed, it is just thin slices of liver that have been harvested from an animal or a human. And since it is harvested from a live organism, it already has everything needed to mimic an in vivo model. For example, it has all the enzymes, it has all the cofactors, it has several different types of cells that all work together to be one organ. The problem with liver slices is that the tissue degrades really quickly and it becomes unusable after 2 to 3 days. It also still requires an animal to be dead to harvest its organs, but at least it will not suffer and feel pain. We then have the human primary hepatocytes, HPHEPs. For a while they were considered as the golden standard for in vitro testing of human liver toxicity. They too are isolated from liver, and this time it's mainly in humans, or in a biopsy or an autopsy. Their functionality is preserved, and that's why they were used as golden standard. But this functionality actually loses over time, and cells de-differentiate, so they lose their functionality, they lose their structure, and they don't express the same properties that the liver would. But it's still quite used in human in vitro testing. After a couple of days, they're already too differentiated to use them. The hepatocytes could be quite useful, but their lifespan is really limited. And because of this, people try to improve the hepatocyte model by creating some structures. There's several structures like the sandwich cultures, spheroid cultures, or even bioreactors where there's a continuous flow. By doing this, we increase the functionality as well as the time as they can be used, from a couple days to several weeks. So that's a big improvement. The problem is that by increasing the complexity, there is more factors to take into account. Because of this, reproducibility goes down, and that's not what we want for a model. Several human immortal cell lines were tested to see if they could be used as a model for liver toxicity. The most known and most commonly used is HepaRG, the human hepatoma cell line, HepaRG. They're really easy to culture and reproduce, which is a great advantage compared to primary hepatocytes. The problem with these type of cell lines is that they really have low level of liver-specific functions, and therefore what we gain in practical we lose in accuracy. And for this reason, they have to be careful when used. Another solution is to use stem cell technology to derive cells from that. Hepatocyte-like cells can be derived from stem cells, and like the immortal cells, they're really easy to culture and to reproduce. They also have a very cool advantage that they can better reproduce human population, as they have some heterogeneity in them, and a lot of the side effects that come in toxicity testing and that is not found right away is in those populations that have some kind of mutation that will modify the response to the drug. They also include a lot of these genes that are involved in hepatotoxicity, and thus are good as model for that. A disadvantage is that they often don't completely differentiate, and so all your cells might not have all the functions that a hepatocyte might have. To conclude this talk, we saw that building an in vitro model of the liver is not something easy. There hasn't been a single model that has been generalized for in vitro testing for humans, and for this we need to use still a combination of several of these models that are out there, as well as to use that data to improve our in vivo testing and reduce the numbers of animals used. Some research groups are really trying to establish a reliable protocol as well as a model to increase the use of in vitro models instead of animals. But in general, the 3D models that we've seen are more reliable than just the single cells. People are also trying to develop synthetic livers, but that's still a bit far away. Thank you, and I'll be happy to answer your questions.